So this is the first section in Chapter 9. This section is honestly just a review from an Algebra 2 class that you may have had, or Math 102. You have a whole chapter on systems of linear equations, and that's just what this section is. So first thing, let's talk about what a system of linear equations is. And it's just a bunch of equations. You might call it a set of equations, but it's just a bunch of equations. And the goal is to find where those graphs cross or intersect, okay? This is called the solution of the system. So we always write the solution as a point if we can. So here are the three types of solutions you can have. You're either going to get two lines that cross, and in that case, it's a point. So that would be 1 is the number of solutions. You could get two parallel lines. If you have parallel lines, you are going to have no solutions. So this is a no solution problem. Or you're going to get a problem where both of the lines that you graph are the same line. So in this case, we would have an infinite number of solutions. Now, all of this here, the systems of equations, consistent, inconsistent, independent, dependent, that stuff I'm never going to ask you, but my lab may. So there are actually 4 ways of solving systems of equations. So we're going to look at substitution and elimination, also called linear combination or the addition method. We're going to do those two in this section, and then we're going to have a section for reduced row echelon form and a section for Cramer's rule. So we're going to do the first two. There is actually one more method, and that's graphing, but we're going to use this just for checking our answers in this class because you have a graphics calculator. So we're not actually going to solve by graphing. We'll just use it to check. So let's talk about the elimination method. The elimination method is best used when one of the variables is alone or almost alone. So notice this one down here, example 1. See how my y is all by itself? So when that is the case, substitution is the best way to solve it. So, and then over here, see how this x is almost alone? We just have a little bit more to do to get it alone. So let's go ahead and solve this letter A. So letter A, solve for a variable. That's my step number 1. That's already done. Now we're going to substitute this into my other equation. So I'm going to take this guy and put it right here where my y is. So I'll have 2x plus 5 times my y is negative 8, and my y we said is 4x minus 6. Notice that I no longer have any y's. Everything is just x's. So from here on out, it's just an Algebra 1 problem. We're just going to get rid of my parentheses, combine like terms, get all the letters on one side, and get all the numbers on the other, and then we're going to divide. So my x value is 1. Now the minute I get that, I go ahead and write it as a point, and I write down the x value, okay? And then all I'm going to do is take that 1, and I'm going to plug it back in, and I have options of where I can plug it back in. Let's see, I could plug the x in here or here, either place. You're going to get the same answer. Now, the easiest would be to plug it in the first one, right? Y equals, y equals, let me write it, y equals 4x minus 6, and I'll just stick the 1 in there. Put the 1 in for the x, and I'm going to get y is 4 minus 6, so my y value is negative 2. So those were 2 lines. That's where they would cross if we graphed them. The second one, notice that I didn't have x by itself. So we are going to solve for the letter with a coefficient of 1. So we could solve it for this y, but we'd be dividing by this, we'd be having fractions, it's going to be a mess. So you don't want to make it harder than it should be. So my first step, I'm going to solve that for x. So I'm just going to move the x to the other side by adding 2y. Or you could write 1 plus 2y. Either way, doesn't matter. So that's my very first step. See, solve for the letter, which we did. Now we're going to plug this, my x, to 2y plus 1. We're going to stick that in the other equation where the x is. Okay, so I grab the other equation. 4x minus 3y is 14. And instead of my x, I'm going to put right now what I had solved x for, 2y plus 1. And again, I now have just one letter. So now I just solve it. It's an Algebra 1 problem. So I'm going to get rid of my parentheses, combine like terms, get all the numbers on one side and all the letters on the other side. I do that just by subtracting my 4. And I'm going to divide by 5. So my y value is going to be equal to 2. So I'm going to put that in a point. And then I come up and again, I can put that y, I could put the y here or here or here. I've got 3 choices. Now the easiest is pretty much always going to be to plug it in that one. Plug it in where I've solved it for a letter. So x is equal to 2y plus 1. And if we know that my y is 2, then I know that my x is going to be 5. All right. So this is called solving by the substitution method. So on your test, I'm going to say solve by substitution, or I may say solve by elimination. Either one, it's the same thing. Oh, excuse me. Actually, it's not the same thing. That should not say elimination up there. Sorry. That should say substitution. I'm getting ready to teach you elimination. Okay, so I'll ask you to solve by the substitution method. Okay, now the next one is the elimination method. So my first step is, and I'm going to use this when the variables are not by themselves, not alone. So you're going to write everything in standard form. Okay, so standard form is ax plus by equals my constant. So I have an x column, a y column, and then my constant. And then I'm going to try and cancel out an x or a y. Okay, and then we'll add and solve and back substitute. So that's my steps. Let's just work one so you know what I'm talking about. Notice these are already in standard form. I have an x column, I've got a y column, got my equal mark, and I got my number. So I want to do it so that my x's are on top of each other, my y's are on top of each other, my constants are on top of each other. So I want to cancel something out. Okay, I want to think. Let's try and cancel out my x's. So I've got a 10 here. It would be great if I had a 10 sitting there. Actually, I need a negative 10, right? So that my negative 10 and my positive 10 will cancel out. What do I have to multiply my 5 by to get that negative 10? I'd have to multiply it by negative 2, right? So that's what I'm going to do. I'm going to multiply everything. Whatever I do to one side of the equation, I've got to do to the other. So I'm going to multiply that whole top by negative 2. And then I'm not doing anything to the bottom. I'm just going to leave it. And then I'm going to add. So when I add, these x's cancel. That's the whole reason we multiplied by negative 2, right? So I've got a negative 17y. That's going to give me what, 34? Then I just divide by negative 17. And my y value will be negative 2. So I'm going to go ahead and stick that in my solution down here, negative 2. I go ahead and do that so I don't forget that, oh, wait a minute, I'm missing something. Because a lot of folks will just circle that and say, I'm done. But you will have 2 answers. You're going to have an x and a y. So now I've got several choices where I can put that negative 2. I could put it here. I could put it in the other y. I could even put it in the one where I multiply by negative 2. It doesn't really matter neither of them, none of those three are going to be, one's not going to be really any easier than the other. So I'll just pick the first one, and I'm going to put my 2 in for my y, excuse me, my -2 in for my y. Then I just solve it, and I solve it using just regular old Algebra 1. So 5x is equal to 20. So when I divide by 5, my x will be 4. So I've got my point, so I'm done. All right, let's talk about how I can solve for this one. If I wanted to, this time let's solve to cancel out my y's. I canceled out my x's. Let's do it to cancel out my y's. So notice that 1 is a 3 and 1 is a 2. So I want to get a number that both of them will go into, which would be 6. You could use 12, you could use 24, you could use all kinds of numbers, but I'm going to keep it as simple as possible. So if I multiply the top by 2, let me show you. If I multiply the top by 2, and that is everything in the top, the x, the y, and the constant, then I've got a 6 for my y, 6y. I want to have a -6y down on the bottom, so I would need to multiply that one just by a 3, not a negative, just by a 3. So I'll get 9x minus 6y is, let's see, 18 times 3 is 54. And then I'm going to add them, and my y's are going to cancel, which is the whole reason we did it, right? So 3x is going to be equal to 52. Excuse me, 13x. So divide by 13. So I get x is 13 divided by 2 is 4. So that's my x value. I still need a y value, so I can plug it into, I've got 4 places that I could choose from. I'm just going to choose the first one. Doesn't really matter which one you choose. And I'm going to plug in my 4 for my x. And no matter which one I choose, I should get the same exact number. So when I subtract my 8, I get a -9 on that side, divide by 3, and I get a -3. So it should cross at 4, -3. So that's how you solve things using the elimination method. Now notice that all 4 of these, I had an answer that was a point. So all 4 of them was one of these guys, right? It was where I had 2 lines that cross. Now we're going to work some that have no solution and an infinite number of solutions. So here we go. So an inconsistent system, just by looking at it, you can't tell that it's inconsistent. Okay. What we're going to do is we got to solve the system. Notice I didn't say how to solve it. I could get my y by itself, but since these guys already have the x's, on top of the x's and the y's on top of the y's, I'm going to use elimination. It would be awesome if I had a 3 right there, right? Because then those guys would automatically cancel. So that's what I'm going to do. I'm going to multiply the bottom by 3. So that's going to give me 9x minus 3y is 24. And then on the top, I'm not going to do anything. I'm just going to leave it. So I'm going to get negative 9x plus 3y is negative 24. Now, when I add these together, I wanted my y's to cancel, which they do, but notice my x's cancel too, so I get nothing on that side. That's how you know you have a system where you don't have one answer, like one point as your solution. It's when all the x's and y's cancel. Well, notice that the other cancels, negative 24 and 24, so I get 0 equals 0. Well, if so what does it mean when I get 0 equals 0? Notice that's a true statement. That's a true statement. So when you get a true statement, we could graph these guys, but I'm just going to show you. If I solve this one for y, I would get y equals 3x minus 8. And if I solved this guy for y, I would get y equals 3x minus 8. Do you notice they're the exact same line? So if they are the exact same line, you can't just write an infinite number of solutions, okay? Infinite number. You can't just write that in the solution, okay? We can have a point, because I might say, what is your solution? Give me, if there's an infinite number, give me 1 point. Okay, give me 2 points. Give me 5 points that would work. So you need a way to find that. Notice that my y, when I solved it for y, do you notice that it says y is equal to 3x minus 8? So what I'm going to do is I'm just going to say x is x. But my y, I'm going to plug that right there, is 3x minus 8. So that's my solution. In other words, I could say, well, give me some points. And so if I put a 0 in here, then I know this one would be negative 8. If I put a 1 in there, this one would be what? 3 minus 8, that'd be negative 5. I could give you an infinite number, right? So I just need it to be written, not just an infinite number of solutions, but a way that you can tell me any points, right? So, all right, let's look at the next one. This time, why don't we solve it we solved the last one for y, so let's solve this one for x. Wouldn't it be great if I had a 14 here instead of a 7? Then those would cancel. So that's what I'm going to do. I'm going to make a 14 by multiplying the top by 2. So that's 14x plus what? 6y is a negative 10. And then on the bottom, I'm not going to do anything because by 14s, it's a negative 14, so it'll cancel. Minus 6y is negative 10. Now, when I add these together, my x's cancel like I wanted. The y's also cancel. So I know that it's going to be an inconsistent system. In other words, you're either going to have no solution or an infinite number of solutions. So everything cancels, so I get 0 on that side. But when I add negative 10 and negative 10, I get negative 20. So when that happens, I get something that is not true. So if I graphed those, this one up here, if I graphed it, I would get y is negative 7/3 minus 5/3. What a joy to graph. And this one would be y is negative 7/3 x plus 5/3. The main thing I want you to notice is you see that the slopes are the same. The y-intercepts are different, okay, so they are different, but the slopes are the same. Those are going to be, I'll draw them this way because it's a negative slope. So those are going to be parallel lines. So when you have parallel lines, where do they cross? They don't ever cross. So this one is a no solution problem, which in the solution, you would just write no solution. No solution. You could also, if you wanted, you could write 0 with a slash through it. That's another way to write no solution. So if you get something that is not true, it's a no solution. If you get something that is true, you have to solve one of these. It doesn't matter which one. You have to solve one of those guys for y or x. Either way, I usually solve it for y and then put an x here and put my y, whatever I get, in the y slot. Okay. All right. So this is just a reminder, okay, of what to do when I give you an application problem. In other words, if you notice, there's a lot of words. So first thing we've got to do is we've got to read the problem very carefully. Try and figure out what kind of information is given. What do you need? You might have to read it several times to figure all that out. Okay. Then read it again to assign your variables to represent your unknown values. Write down what each one represents. You might even need to read it again to make a sketch, a table or a diagram. Normal or table or diagram or sketch. you need to read it more than once. Absolutely. Usually I read it 2 to 3 times. Okay. Then you're going to write a system of equations. And a system of equations means you're going to write two or more. Right. Then you're going to solve the system. And then you will state your answer. Okay. So basically, you're going to answer the question. Okay. And please check it in the original problem to make sure that it makes sense. Okay, make sure that it makes sense. All right, so because we don't want grandmas that are 5 years old. That can't happen. Anyway, okay, so let's get me fired. Okay, so this semester I decided that I want to sell grades. So I'm gonna, which would get me fired, by the way. I want to sell grades. So I decided to sell 293 test grades. So I sold 93 more A's than B's. How many of each grade did I sell? So I know I'm going to have A's and B's. Nobody bought C's, which is a little surprising, but nobody bought C's. Of course, nobody's going to buy a D or an F. But I'm going to say, how about let the number of A's be the letter A, and let the number of B's be letter B. All right. So I'm I'm making sure I've got some variables. You can use X and Y's. You don't have to use A's and B's. But notice it says I have a total of them. So I'm going to add them up, right? All my A's and all my B's is going to be 293 test grades. Okay. Now I sell 93 more A's than B's. So my A's are going to be more than B's. So I think of it like this. A's are going to be my B's plus 93. That's the way my brain works. Okay. Some people say, well, my B's are going to be my A's minus 93. It really does not matter. Whichever one makes sense to you. Okay. This equation works, that equation works. It doesn't matter which one you use. But I'm going to go ahead and use the A equals B plus 93. So now I need to solve this system. That's my system of equations. Notice that I have my A is all by itself. So since it's all by itself, I've already done the first step of solving by substitution. So I'm going to put this in for my A, right? So this is my system. So now I'm going to solve it. So I'm going to have A plus B is 293, but instead of A, I'm going to stick B plus 93, right? So that's going to go in for my A. Plus my B is equal to 93. Notice that all I have is one kind of letter. I just have it B's. So I'll have 2B plus 93 is 293. Subtract my 93 and I get 200. So 2B is 200. So that means what? I'm going to have 100 B's. All right. And now to figure out how many A's I have, so that was my first step. To figure out my number of A's, notice my A is equal to B plus 93. So my A is going to be 100 plus 93. I just took that 100, stuck it in right there. So I've got 193 A's. So Miss Kitts sold blank A's and blank B's. That's what it'll have in my lab. And you just put 193 A's and 100 B's. And it makes sense. If I added all those together, I've got 293. So that makes sense. Okay. This one has a little bit more words. Okay. In 2019, the average of the median salaries for the position of environmental compliance specialist in Boston, Massachusetts, and Indianapolis, Indiana, was $76,553.50. The median salary in Boston exceeded the median salary in Indianapolis by $11,989. Determine the median salary for the environmental compliance specialist position in Boston and in Indianapolis. That is a lot of words. So let's see if we can pare it down. Okay, it says in here the average of the median salary. So we're talking about salaries, right? Salaries for this job, whatever that job is. I don't know, environmental compliance specialist, whatever that person does. So we're talking about the average salary for that job in two places, Boston and Indianapolis, was this much. Okay. The median salary in Boston exceeded the salary in Indianapolis by this much. Okay, so right now we know we're talking about salaries in two cities. So I'm going to put the average salary for Boston is B, and the average salary for Indianapolis is I. Okay, you could just put Boston is baby B, Indianapolis is baby I. Okay, you don't even have to write all that out. Anyway, all right, so notice the first sentence. Let's look what it says. The average of the salaries was this much. Well, how do you average two things? You add them up and divide by 2, right? So that's what we're going to do. So that first sentence is going to be B plus I divided by 2 is going to be a bunch of money. I am in the wrong profession. Okay. Next, let's look at this one. Let's see what this one says. The median salary in Boston exceeded the median salary in Indianapolis by that much. So Boston made more than Indianapolis, right? Whoever lived in Boston or whoever worked in Boston. So my Boston is going to be my Indianapolis plus that 11,989. Again, if you think, I don't think of Indianapolis being Boston minus that. You could do that too. It doesn't matter. Either one of them works. Okay. So now we've got two equations. Unfortunately, one of my equations has a bunch of fractions in it, which is not my favorite. We all know that. So, we know how to get rid of it, right? We know how to get rid of that 2 on the bottom. Do you remember how to do that? We're just going to multiply both sides by 2. So I'm going to multiply that side by 2, multiply that side by 2, and I'm going to wind up, that's going to cancel. So I'm going to wind up with B plus I equals, let's see, that much money. Let's see, 76 times 2. It's a bunch of money. 153, 107. Okay, so now I'm going to work with those two formulas or those two equations. Okay, so that's my system of equations. I have 2 of them. Notice that my B again is by itself. So when it's by itself, I tend to think, let me take this guy and substitute. Whoops, hello. I'm going to take that guy and put him in right where B is, right? Right where B is. So first step, I've got B plus I is 153, 107. And instead of my B, I'm going to put in the I plus 11,989 plus another I is 153, 107. Notice that now I'm going to have 2 I's, 2I plus 11,989 is 153, 107. And then I just subtract, right? So I'll get 2I is, let's see, when I subtracted, what did I get? I got 70, no, I got 141,118 when I subtracted. And then you just divide by 2. And I get $70,559. That's how much my person in in Indianapolis made. And then I'm just going to plug that in. And again, I can plug that value that I found into any I. So I could put it here or here. The easiest place is going to be in that first one, right? So B equals I plus 11,989. And I just stick my 70,000 right in there. And I add my 11,989. So the person in Boston, the average in Boston is $82,548. So the average salary for Boston in Boston is $82,548. And the average salary in Indianapolis, I'm not going to spell that, is 70,000. I could. It's a long word. All right. So really that's all the new stuff. It's not really new, it's just a review, but I wanted to remind you that you can always check all these answers. So every one of these answers you could have checked. Even these guys, even these you could have seen that they were parallel, and you could have seen this one was an infinite number, but you would still have had to calculate. You still would have had to figure out what that guy is, right? Erase all that. Okay. So, but we could check them all, and here's how you check it. And we've talked about this before, but you might not have thought of using it to check systems of equations. So the main thing is you have to be able to plug in each equation. Each equation has to go into my y, right? So in these that we've solved on all of these, I'll go up to maybe this. Let's go back up to these. Okay, so these two equations, that equation and that equation, you would have to solve it for y and then put it in your calculator. You'd have to solve these for y and then put them in your calculator. Okay, you already do that here. See, this one's already solved. So you'd have to solve that one for y and put it in the calculator. And then you just need to see where they cross. So once you have solved it, then you stick it in your calculator, right? Once it's in the calculator, then you hit graph. Usually I start off my window with the standard window where it's -10 to 10 on the X and -10 to 10 on the Y. Notice this one is almost off the screen, but you can still see where it crosses. Okay. Do you remember where you go anytime you want the calculator to tell you something from the graph? Remember, we go to second and calc, which is trace. So that's the second and the calc, second and trace. So we get there, and then you have a list. I don't think I had the list. Anyway, you've got a list sitting there. Okay. So you go to the one that says intersection, right? And that's the one you click on, intersection. That's what this is telling you to do, right? Intersection. And then these are the questions it's going to ask: first curve, second curve, and guess. And then it will give you the answer. So that's the end.